Okay, in this section 9-5, we're going to begin learning about the trigonometric ratios. And so remember, this unit began with the Pythagorean theorem, which told us that as long as we have two sides of the right triangle, we can find the third side with a squared plus b squared equals c squared. And then we started looking at the special right triangles, like 45, 45, 90, and 30, 60, 90, where we found out that we just need one of the sides to be able to find the other two sides. Okay, but remember, we were only able to do that with those two special angles, 30, 60, 90, and 45, 45, 90. Well, with the trigonometric ratios, it doesn't matter what the angles are. You can still find the other two remaining sides if you're given just one of the sides. And that's what we're going to be moving into. However, in this section, all we're going to do is just look at the trigonometric ratios, see what they are, and write them out. Okay, so we're actually not going to be finding anything that's missing until the next section. Okay, so again, the trigonometric ratios, what are they? Now, before I get into this, let me just say that there are some students that think that, oh my gosh, this trigonometry stuff is just the most difficult thing they've ever seen in their lives. Okay, but what I want you to understand about this is when we start looking at these trigonometric ratios, like sine, cosine, and tangent, okay, what you need to think about sine and cosine and tangent is as a function, much in the same way like square root is a function, right? So we'll talk more about that as we get into it. But for now, the trigonometric ratios are fractions made from the sides of a right triangle. So those ratios are just fractions. And all we're really doing in this section is writing out the fractions. That's all that we're doing. So the three trigonometric ratios that we're going to look at are sine, cosine, and tangent. Okay, so there's more, but these are the three that we look at in geometry. All right, and so the first thing that I want to make sure that I point out is this is the full functions written out, but they have abbreviations, the first three letters, right? So keep that in mind. Also, this symbol you may not be familiar with. It's a Greek letter theta, and it stands for angle. So whenever you see this, it stands for the angle. It's another way to a symbol that's used to represent an angle. All right. Now, so again, in this section, all we're going to do is write the fractions. That's all we're going to do. Okay. So sine of an angle, right? And let me go back and reiterate. Remember, okay. Sine, cosine, and tangents are functions much like square root is a function. So square root of 25 is 5. Okay? Square root by itself is nothing, right? It's not a number. Okay? But square root of 25 is a number. So it's the same thing with sine, cosine, and tangent. Like cosine or sine by itself is not a number. But sine of 25 degrees is a number. It's a fraction. All right, and that fraction is what we're trying to write out. So when we see that, that's what you need to make sure that you understand, that it's a function, kind of like what square root is, a function. All right, and so sine of an angle, right? Whatever the angle is, it can be any angle that you have. All right, the sine of that angle is equal to the opposite side over the hypotenuse. Right, the opposite side over the hypotenuse. Okay, cosine is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over the adjacent. So, like in a right triangle, whatever angle that you're going to be looking at, okay, whatever angle that you're going to be looking at, let me show you. Okay, so let's say that this is my angle right here that I'm looking at. Okay, this is my right triangle. Okay, the opposite side is always across from your reference angle. Opposite side is always across. The adjacent side is the leg that's connected to the reference angle, right? Okay, and the hypotenuse is the side that's across from it. All right. So the hypotenuse is the side that's across from the 90. Okay, so opposite is across from the reference angle. Okay, adjacent is the leg that's connected to the reference angle, and the hypotenuse is always across from the 90. All right, so those are the things that we need to make sure that we can recognize here and understand. All right, let's see. And so this is the equations written out. These would be the equations with the abbreviated form, the way you would see them in a mathematical statement. So the sine of the angle is opposite over hypotenuse. Cosine of the angle is adjacent over hypotenuse, and tangent of the angle is opposite over adjacent. There's kind of a mnemonic that helps you remember that called SOHCAHTOA. It just helps you to memorize the equation. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, so remember, in this section we said that we're not actually going to be finding anything that's missing. We're only going to be writing out the fractions. Okay, so let's take a look now at this triangle. We've been given all of the sides, 3, 4, and 5, and we're going to be asked to write out the trigonometric ratio in the first case for the sine of A. All right, so the first thing that you want to do is locate your angle. Angle A is here. Okay, and it's important to locate the reference angle because that will tell you which side is your opposite, your adjacent, and your hypotenuse. So this thing is going to be a fraction. All right. And the fraction for sine is opposite over hypotenuse. So my fraction is going to be made out of these sides. I just get to figure out which two. So the first side should be the opposite side. Well, which side is across from the A? Okay, it would be 4. So 4 is across from the A. That's the opposite side. It goes in for the opposite. Now the hypotenuse. Which side is the hypotenuse? Well, the hypotenuse is always across from the 90, and it would be 5. So what's sine of A equal to in this triangle? 4 over 5 is the correct answer. All right. So again, all we're going to be doing is writing out the ratio. That's it. Okay. Can we write the correct fraction? Can we get the correct opposite over hypotenuse or adjacent or whatever is involved? All right. Your answer can be expressed as a fraction or a decimal of 0.8. Okay, you may see both. All right. Cosine of A now. Okay, so again, my reference angle is still A, but now the fraction that I'm writing is the cosine fraction. Well, what's cosine? It's the adjacent over the hypotenuse. Adjacent over the hypotenuse. It's the adjacent side. So I need to figure out which side is adjacent to A. All right. So the adjacent side is the leg that's connected to that angle. All right. So the leg that's connected to this angle is 3. If you had trouble figuring that out, then eliminate the opposite side, eliminate the hypotenuse, and then what's left is the adjacent. Okay. Remember, both of these, the adjacent side and the hypotenuse, are both connected to the angle, or it makes up one side of the angle. All right. But the adjacent is only going to be the one that's the leg, not the hypotenuse. Okay. So we have the adjacent, which is going to be 3, over the hypotenuse, which is still the same as 5. So the cosine of angle A is 3 over 5. Okay. This can also be written as a decimal. You might see it expressed that way as 0.6. Okay, could be either one. Okay. So again, even though we don't know the value of the angle, we don't know how many degrees it is, we know that the cosine of this angle is 3 over 5 because we know the sides. All right. What about tangent of A? Well, what's tangent equal to? Tangent is equal to opposite over adjacent. So what's the opposite side for A? It would be 4. And what's the adjacent side? It would be 3. 4 over 3 is equal to 1.33. All right? So there you go. Now, let's take a look and fill them out for this one. Now we have sine of C. So the main thing to notice here is that we have a different reference angle. It's not A anymore. C is the reference angle. So the reference angle can change your opposite and adjacent. So when I go to write this out, here's what I need to look at. Again, sine is opposite over hypotenuse. So the question is, what's the opposite side for C? The opposite side for C is 3, and then the hypotenuse is 5, and so that would be 0.6. All right. Okay, and so you might be thinking that, well, I thought 4 was the opposite side. Well, 4 is the opposite side for angle A, right? But 3 is the opposite side for angle C. So that's why I say it's important to make sure you know which angle is your reference angle, because the opposite and the adjacent can change. So something to keep in mind. Let's see what we got here. I've got now the cosine of angle C. Now remember, cosine is adjacent over hypotenuse. I need the adjacent side for C, which is 4. 4 is the adjacent side. And it's adjacent over hypotenuse. The hypotenuse is still 5. So that's 0.8. All right. And for C, the tangent of C. So tangent is opposite over adjacent, which is going to be 3 over 4. So 3 is the opposite side, 4 is the adjacent side. That's going to be 0.75. All right, so there you go. All right, so a little more practice with it now. Here are the type of problems that you can expect to see. Asked to find the indicated ratio. So now I'm asked to find the sine of A. All right, here's angle A, and remember, what is sine? Sine is opposite over hypotenuse. The opposite across from A is 8, and then the hypotenuse is 10. We can write that as 4.5, or we can write it as 0.8. All right. Let me see here. What else we got? We want the tangent of F. All right, so F is here. Okay, tangent is opposite over adjacent. So the opposite is 12. The adjacent is 5. We can write that as 2.4. All right. The next one, cosine of C. C is here. Cosine is adjacent over hypotenuse. So the adjacent side would be 8. The hypotenuse would be 10. That divides out to be 4/5, reduces down. Or if you want to write it as 0.8, then you can. All right. Let's see. Next one we need is the sine of D. So sine is opposite over adjacent, or opposite over hypotenuse. So opposite of D is 5, and the hypotenuse is 13. 5 over 13, which equals to 0.38. All right. So there you go. All right. So as long as you can take a look at an angle and tell which side is the opposite, which side is the adjacent, and which side is the hypotenuse, then you should be in good shape. Because all we're doing, remember, is writing out the fractions. That's it. And you should be able to take them to a decimal if need be. Because your answer choices could be as fractions. Remember, they need to be reduced down to lowest terms if they can. Or they could be as decimals. You've got to be able to handle it either way. Okay. Here's something else I want to point out to you and keep in mind. Remember, when we're talking about angle A, B, and C, right triangles also have a side A, a side B, and a side C. And the thing to remember is side A is across from angle A. All right? And side B is across from angle B. And side C is across from angle C. So the capital letter angle matches the lowercase angle, or the lowercase letter side. So the letters match each other. The capital letter and the lowercase letter match each other because this capital letter angle is across from this lowercase letter side. So in other words, I can't have this labeled as A. Why? Because it has to be across from angle A on the opposite side. Okay? So having said that, now we should be able to fill out all three sides and all three angles for this triangle correctly. All right, so angle A is given to us. What is it? It's 60 degrees. All right. Angle B is 90 degrees, and angle C is 30 degrees. That's pretty easy to read off because it's written for us. Okay. However, what's side A going to be? Remember, capital is for the angle, lowercase is for the side. So how do I know which one of these is side A? Well, remember, side A is across from angle A. And angle A is here, so side A would be 8 square roots of 3. All right. Side B is across from the 90, it's 16. All right. And side C is across from the 30, which would make it as an 8. And of course, if you recognize this as a 30, 60, 90 degree triangle, then your pattern actually works out there. So x square root of 3, 2x, and x. All right. And so that's it for this section. So like I say, all you'll need to be doing on the quiz here is to go in and write out the fractions. Make sure you reduce them to lowest terms, or if the answer choices are decimals, turn it into a decimal with a calculator. All right? There you go.